Okay. I appreciate being here this morning. Y'all have given me a beautiful morning in South Dakota. It's pretty nice out there. I did check the weather back home. I actually live in Grand Haven, Michigan, and we are about 25 degrees warmer than y'all are here in South Dakota. But it's still winter, but spring's getting here. When Peggy first asked if I could come to this and discuss some of the things about growing plants, etc., I really had no idea what I wanted to talk about, so I ended up with this here. How do plants grow? From what I understand with the NRCS, they have some money available for helping to broaden and support some urban agriculture. And I think that's a good thing from a standpoint of, I firmly believe everybody on the planet should be getting their hands dirty at least once or twice a week. And I think that just makes you a better person. And so anyway, but you know, some of the things that we've done down through the years, and we've been in the biostimulant and plant food business for going on 45 years now. We really helped initiate a lot of the biostimulant growth in both commercial agriculture and horticulture, and we're still very, very active in that. One of the things that, going back, gosh, several decades, we would be doing various things on crops, and we'd go, wow, that worked really well. Or sometimes, unfortunately, it was, wow, that didn't work very well at all. That was horrible. So we started getting into the practice of trying to figure out, okay, what are some of these differences? And part of that is just really understanding how each individual plant grows. Plants are not chaotic. They're very orderly. And which button do I push?
You know, but it's not plugged in.
Oh.
Being first speaker of the morning.
Well, that one got advanced. But plants are very orderly in the way that they grow. So, you know, if you're going through the season and you're starting to see challenges, the plant will, we used to use the phrase a lot that the plants are always talking to you. They're always trying to tell you how they're feeling, what some of the issues are, et cetera, et cetera. But to hear that or to understand it, you need to understand how that plant's growing and what the potential issues are. We're going to touch on this a little bit later, but you know, we don't want to be in a reactionary frame of mind. We always want to be anticipating what's going to come next with these plants. And the plants do give you a lot of signs that this is how I'm feeling. And those of you that know me, and there's several guys in this room that do, you know, I kind of look at plants almost as people. As a matter of fact, I like plants better than a lot of people. But anyway, when I was putting this together, I found a couple of quotes. One, Claude Monet, the of course, famous artist, he said, my garden is my most beautiful masterpiece. And he was quite an avid gardener. But one I really liked, too, was a Russell Page. He was a landscape architect, gardener from back in the early 20th century. He says, if you wish to make anything grow, and this is the part that I like, you must understand it, and understand it in a very real sense. Green fingers are a fact and a mystery only to the unpracticed, but green fingers are the extension of a verdant or a green heart. And what I liked about that is that comment again, you have to understand it. I just can't stress enough that plants are not chaotic. They grow in a very, very orderly manner. And, you know, there's a lot of reasons that those of us who grow plants, there's a lot of reasons we do it. Some, of course, is to make money, to support themselves and their family. Some of it is just on a smaller scale. We want to put food on the dinner table. But one thing that we all have in common, or at least those, and this may not be a perfectly nice statement, but those of us that are really good at it, we love it. And believe me, there's a lot of people out there that they're really not very good at it. I mean, they get by and things like this, but those of us that truly are good, we love what we do. And, you know, some of the things that I like about growing produce, particularly in a garden or in somewhat of an urban environment, is that we go in the grocery stores and we see all of our selections of produce, etc., and you compare that to what's in a seed catalog. That's just a small sampling. I mean, growing your own food, it gives you an opportunity to not only determine how you're going to grow it, whether you're going to grow it organically or if you happen to be in love with chemistries, et cetera, but at the same time, you can really pick and choose. I have never eaten that vegetable. So it gives us the opportunity to really experience so much. And, you know, once you really get into growing plants, it can be a completely life-changing process. I mean, you just look at things in a different manner. You know, most plants are going to grow in the soil. We do have growers that grow in artificial medium. We have growers who grow hydroponically. But for the most part, I prefer the soil. And part of the reason I prefer the soil is the soil itself can be very forgiving. You can make a mistake, you can stumble, and it's not going to completely terminate whatever you're trying to do. You can make an adjustment and fix it. Several examples is sometimes we get a little heavy on the fertility. We may see a little leaf burn, something like this, but we can always come back in and kind of undo that and fix it. Obviously, I want a soil that's got good depth to it. We get these events called rain, thunderstorms. So when we do get too much water, hopefully that's going to allow, the soil is going to allow that water to drain out. But soil is pretty forgiving, and I think it is a constant process. Those of us, again, that are involved in growing, we never think our soil is good enough. We always want to make it better. And I think that's possible. It's always possible to make it better. One comment about growing medium hydroponics is your water quality is really, really touchy there. You need to normally acidify that water, get it down into the 6, certainly the 6.5 range. You start using a lot of alkaline water, which most of our water is. It's going to give you some very definite growth issues. So talking about soil, and I appreciated what Anthony was saying yesterday on the soil analysis, et cetera. But every soil has a productive potential, and not every soil is identical by any means. Some soils have a very high productive potential. Some of them have a number of issues, and those we can address as the grower. But every soil's productive potential is going to be determined by a combination of soil physical properties, chemical properties, and soil life, or the biological properties. Air and water is extremely important. Some of the things that we're talking about there when we're talking about physical structure is the texture of the soil. Is it a sand? Is it a clay? Is it a loam? Just how does it feel in your hand? The color of the soil actually can make a pretty significant impact. Soil aggregation, how well does it hold together? They call that petting. And soil porosity, the depth of the soil. Do you have compaction issues? Even worse, do you have crusting issues? All of these things are going to have a significant impact upon that soil's productive potential. On the chemical side, of course, we're talking about the native fertility that's inherent in any soil, and all soils have some inherent fertility. We're talking about CEC, the cation exchange capacity, soil pH, electrical conductivity, percent base saturation. We're also certainly talking about organic matter and carbon. From a biological standpoint, of course, we're talking about the bacteria, the fungi, the nematodes, algae, arthropods, earthworms, all kinds of little critters down there in that soil. And when all these things come together in a really positive way, then you can enhance your soil's productive potential quite a bit. And as I said, at ISP, we've been working on the biological side. We've been working on the chemical side for about 45 years. And one thing, and I advanced the slide, one thing that we need to understand, anytime we make an impact in one of these areas, let's say we come in and we do a tillage practice, we're going to have almost an immediate change in the soil's chemical composition. And when I say the chemical composition, I'm talking about what's available to that plant at that point in time. We're going to have a very significant impact upon soil biology. And one of the things that's going to happen as we till is we're going to get this oxygenation of that soil environment, so we're actually going to get what I refer to as a bio bloom. Now, long term, that tillage practice could be detrimental, but some of the benefits short term can be very, very positive. When we apply fertilizer, we actually create a little bit of soil texture difference for a period of time. Now, all soils are going to want to try and go back to their original state to some degree, but we cannot do anything in one of those areas without it impacting the others. So at ISP, as we've been working a lot with soil biology to enhance the microbial, the living parts of the soil, we see benefits in the physical area. We see a reduction in crusting. We see better petting. We see less erosion, things like this. That soil physically just becomes in a better state. We normally see better chemical or nutrient availability to those plants. So that's something to remember, is that all of those areas, they impact the other. You know, when we're talking about plants, really what do they consist of? For the most part, and this is data talking about corn, when corn is at the height of its beauty, I mean, it's starting to tassel, things like this, that corn plant's going to be about 75% water. 25% of it's going to be solid material. Of that solid material, about 11% is going to be carbon, 10% is going to be oxygen, and about 2% is going to be hydrogen. Now, you've probably noticed I haven't mentioned nitrogen, I haven't mentioned phosphate, I haven't mentioned potassium, I've mentioned no nutrients, but all of that combined will comprise about 2% of that corn plant. Now, that's not saying it's not important, because it is. We've all seen plants that are undernourished. That's a very, very significant part. But when we're talking about, in this little diagram here, air and water is highly, highly impactful as far as your potential for success. So anyway, once we've decided how we're going to grow it in the soil, we're going to grow it in artificial medium, etc. Site selection is really, really important. Don't put your tunnel, don't put your garden in an area that is going to collect water. Water is absolutely essential for plant development, but it will also kill your plants if it gets excessive. So avoid low areas. Try and find a site where you're getting 6 to 8 hours of sunlight per day. Don't put it in the shade. Plants do require sunlight. Morning sunlight's better than afternoon sunlight, and I think all of us can relate to that. We can go out in the morning and the sun feels pretty good. We go out in the middle of the afternoon and wow, that's hot out there. And our plants are reacting, again, very much the same way that we do. This is not absolutely essential, but Kansas State did some research going back about 20 years ago. How do you place your rows? North, south, east, west, etc. They actually found that northeast to southwest is the best way to capture the maximum amount of sunlight. But, you know, if that doesn't work, it doesn't work, so we'll go on to something else. Plants are going to require a lot of water. A lot of our produce crops requires about 2 inches of water per week. So particularly tomatoes, some of our melons, things like this. I prefer well water, city water, municipal water is probably my second choice. My least favorite choice is surface water, ponds, rivers, streams. And it may not be the case out here in South Dakota, but I know back in Michigan, Indiana, Ohio, almost all of our surface water is contaminated now. And when I say contaminated, I'm not talking necessarily with chemistries, but with a pathogen called Phytophthora. And once you have Phytophthora, you're not going to get away from it. I mean, it can really, really damage a lot of crops, peppers, most of your melons, pumpkins, winter squash. It's just really a hard battle to win. But water is something that's going to have to be taken into consideration. Obviously, all plants require water for proper growth and yield. We were talking about that corn plant. The majority of the plant is going to be water. And one of the things about water, there's a guy that used to work with us. He said watering is the most difficult job on the entire place. Nothing is harder than watering properly. We've gotten to where we're working with a lot of ornamental greenhouses, and that is a real challenge in some of those places. And they do eventually get to where their best employee is going to be the one doing the watering. And because the damages can just be highly, highly significant. But when soil's dry, nutrient flow from the soil to the plants, it really just pretty much stops. All nutrients move through the soil solution, so we have to have some moisture there for those plants to feed themselves. A lot of guys on tomatoes, we see blossom end rot. Some of that is temperature. Some of it is inadequate soil moisture, but you can be growing this beautiful tomato plant and you end up with a lot of blossom end rot. The easy answer on that is calcium, lack of calcium, but generally speaking, a lot of times it's just going to be there's just not enough water to move that calcium to the plant, or the soil is still so cool that it's not releasing properly and moving into an available form. Excess water, of course, can just be absolutely horrible. Excess water, not only can it kill a plant, but you start getting large variations in the amount of water in a growing environment. You can see things like hollow heart and watermelons, potatoes. You can really get into some quality issues that's going to make, it's not going to make the produce inedible. You could take it to your table, but if you're trying to grow to resell, there's not anybody out there that's going to want to buy that. A lot of our watermelon growers, they will ship a semi-load of watermelons, and the buyer will go in there. He'll pick out 6 to 10 watermelons. He'll cut them in half. If he finds one with hollow heart, that entire semi-load will be rejected. So the buyers are really, really picky on stuff like this. So really, it needs to be tremendously important that we maintain more or less a uniform soil moisture environment. One of the things that I've read about potentials of urban agriculture, if it's actually in a municipality and there was a building sitting on that site some years ago, there's a very high percentage of chance that it's probably going to be contaminated in some way. I'm not going to spend a lot of time on this, but I've read several places that cleaning up that soil, decontamination is probably something that's going to be advisable prior to actually trying to get into a growing environment. ISP, we used to do some of this work going back into the mid-'80s, abandoned oil well sites. There's several materials that we have that's very effective in cleaning up the soil. Most of them are humic materials and are biostimulants. Several of them Restore 3G, Phytogrow Extra, Restore Extra, Metabolic HV1. We were able to see using those materials that generally speaking in less than a year we could have something growing on those abandoned oil well sites. And humic acids, some of the common issues potentially in an urban setting is going to be mercury, it's going to be lead. Humic acids are very effective at just tying up those materials and kind of taking them out of the soil profile. Air pollution can be an issue. Plants are pretty sturdy in that area, so I don't concern myself too much with that. So now we've decided how we're going to grow it. We've decided where we're going to grow it. So now we have to decide what are we going to grow. And it kind of makes a difference. I mean, y'all are certainly free to grow anything that you want. at ISP, part of what we have done down through the years is we look at each plant differently and basically asking ourselves the question, what part of that plant do we consume? Are we consuming a tomato? Are we consuming, which would be a vegetative portion of a fruiting, reproductive part of the plant? Are we growing lettuce, which would be a vegetative part of the plant? Are we growing onions, which would be a modified stem? Are we growing carrots, which would be a root? Each one of those types of plants, we can manipulate what we're doing from a management standpoint to accentuate the aspect of the plant that we're wanting to grow for either consumption and or marketing. But there's two things that are universal. And I might say this, we do grow lettuce a little differently than we grow a tomato or an onion. I mean, every one of these types of crops, we have developed a specific program to bring forth the part of the plant that we're wanting to grow. But there's two universal aspects when growing plants. One, we have to understand that a plant is nothing but a solar energy conversion factory. That's all a plant is. It captures sunlight through photosynthesis. It transforms that into potential chemical energy, predominantly in the form of sugars. I mean, that's all a plant is. And that's actually what supports all life on this planet, because our livestock will eat plants, the wildlife will eat plants, we eat the plants, we eat the livestock who ate the plants, et cetera, et cetera. It all started as solar energy. So recognizing that fact, if I'm growing a tomato plant, I have a choice. I can grow a tomato plant, say maybe this big. I can grow maybe a tomato plant that's 9-10 foot tall. I can grow a tomato plant that's maybe 4 or 5 feet tall. But the height is not necessarily important, but I need node spacings. There's a specific point where the plant's going to put on a fruiting truss. So I want to grow the plant in a manner that I have a high number of fruiting trusses. And we refer to this as just building the frame. Second thing to understand is I don't care how good you are at growing something, your plant's going to have stress factors. You're going to have temperature stress. You're going to have water stress. You're going to have humidity stress. You're going to have light stress. You're going to have maybe a little bit of pollution stress. All of those can be incredibly damaging to how well your crops are going to perform. And those are all referred to as abiotic stress factors, factors outside the plant itself. Then there's biotic stress factors, and the main one there is nutrition. I like to tell a story about tomatoes, and part of why I talk about tomatoes a lot is we probably specialize in tomatoes and peppers. But every time you add another fruit onto that plant, it's just like another person sitting down at the dinner table. And if you get enough people sitting around that dinner table and mama has prepared dinner for 2 or 3 people, somebody's going hungry. And once that plant starts going hungry, all kinds of bad things start taking place. Plant health is the foundation of disease control. We got a lot of chemistries. We have a lot of tools out there that we can use to fight disease. But really, the foundation of it all is a really healthy plant. It's capable of fighting off all kinds of infections if it's healthy enough. Part of what we look at ISP is we want not only a high yield, but we also want to make that produce crop, that tomato, that onion, whatever, very nutrient dense. That's part of the reason that we eat food, is so we can get the necessary compounds that's going to keep us healthy. And a lot of that also gets back to flavor. How many of you bought a tomato in a grocery store in the last month? Oh, I'm sorry. I feel so bad for you. Yeah. But, sometimes we do want a tomato and we don't have any in our gardens. But, I really haven't bought many tomatoes in a grocery store in quite a while. But, the common complaint is they don't have any flavor. Well, part of that is because they were harvested immature, et cetera. But part of it also is a lot of the commercial tomato growers, they really don't do a very good job growing tomatoes. I mean, they're interested in getting the crop in, growing it to a certain point, getting it out, and we're done. And that's really not a very good way to grow tomatoes, or peppers, or watermelons, or anything else. But as I say there, you have a very healthy plant, you're going to see a lot less insect pressure, you're going to see a lot less disease pressure. So going back to the soil, the physical structure, well, how can I know if I've got some issues there? Well, just dig a hole. I mean, it's real simple. Dig a hole and then get down in there and play with that soil. Does it break up easy? Does it dig up in large chunks? Does it come up fairly friable? You see that picture there in the lower left. That's actually looking like it's probably pretty good soil. It's got nice friability. It's got good texture. It's got good color. There's a lot of really nice things about it. But I want your hole to be at least 15 to 20 inches deep, because a lot of those compaction layers are sitting down there at that 8 to 12 inch depth. And if you're trying to dig that hole, are you finding a hindrance getting down deeper? Part of why that's really important to me is I want a soil that's going to drain. We're going to get these weather events. Even guys who are growing in high tunnels, every year somebody will call, I forgot to shut my water off. And they let it run for like 24 hours, and it's just a muddy mess in there. We've got to have good soil drainage. It's a little harder to tell if a soil's going to crust, but you can, when you're digging that hole, just kind of play with the surface a little bit, see if it wants to come up in sheets, so to speak, because crusting's going to inhibit airflow. And air, again, is a significant part of what we want in our growing environment. The best way to test, I mean, you can send this off to labs now, and they will give you ratings as to how much soil life you've got. But a really good, down and dirty, simple test is grab a handful of that soil, and I'm going to get it right up to your nose. And I say, if you don't get some on your nose, it wasn't close enough. Get that right up in there and smell. Does anybody know what good, vibrant, healthy soil smells like? I see some heads shaking, yes. It's not supposed to smell like nothing. It's got a very distinctive odor. And what that is that's waste products from actinomycetes, which is a very beneficial organism in soils, helps break down high lignin compound residues, et cetera, et cetera. But if you have a good population of actinomycetes, there's a good chance you've probably got some good fungi, you've got some good bacterial activity going on, et cetera, et cetera. If that soil has very little odor, then that's an indication that your soil life is probably not where it needs to be, and you probably need to start working at bringing that more to the forefront. Of course, when looking at chemical makeup, we heard about that yesterday, and I appreciated a lot of what he said. This is a soil sample from east central Indiana, Wayne County. The lab that we used here was A&L Labs out of Fort Wayne, Indiana. So I don't see these as often as I used to. I'd see hundreds of them every year. But you know, the thing that I really like about taking a soil analysis, particularly if it's in an area that I'm not familiar with, is there anything there that's going to cause me an issue? I kind of normally say, but there's a lot of, well, I'll say it anyway. Is there anything there that's going to jump up and bite me in the butt? And really, in this soil sample here, I don't see anything at all that I'm terribly concerned about. I do have a little bit of a high pH, which is okay. I mean, I actually like growing in a little bit of a high pH because it allows me to do some other things from a management standpoint. But the pH is a little bit high. It's a good, moderately heavy soil, CEC of 19. The one thing that I really notice is I got 0% there on my hydrogen. What that tells me is any cationic elements I put into that growing environment, there's no place for them to attach to. Everyone remember a game called musical chairs? Maybe we played when we were younger, you know. This has no chair open. So when it comes time to add potassium, to add calcium, to add magnesium, I've got two options. The plant can utilize it or it's leachable. And leachable is never good when we're talking about our nutrients. It contaminates groundwater. It costs us money. We're spending good money on something we're not able to use. So what that tells me, that 0% hydrogen, it tells me I've got to kind of spoon feed my cationic nutrients. This is nutrient requirements for average to good growth. A lot of people in this room, I know most of the guys I work with would not be satisfied with average to good growth. Most of the guys I work with are growing for money, and so they want a very high yield. One thing I really appreciated about this website that I got this data from Michigan State, they made the comment, it's absolutely impossible to tell you what you need. It's absolutely impossible to tell you, in some respects, how much is actually in your soil, because we're doing fairly weak extractions. The soil has a whole lot more than that in it. Based upon your biological activity, you may get much more nutrient release than you might otherwise. But it is a good starting point. So I'm going to talk about tomatoes as far as my example goes. You can see tomatoes use a lot of potassium. And a lot of our growers normally are targeting in the neighborhood of 600 to 800 units of potassium per growing season. But then they're trying to grow 35, 40 pounds of tomatoes per season. Now, that doesn't mean you have to do that. I tell everybody, I don't care what your yield goal is. If your yield goal is to get 12 tomatoes per plant, man, I'm happy with that. If your yield goal is to get 80 tomatoes per plant, I'm happy with that. Your job's a lot harder than the person that wants 12. But I'm happy with it. It's up to you how aggressive you want to get as far as your production goes. So anyway, looking at that, from that soil sample, if I was to grow in that soil, I need approximately 228 units of nitrogen. According to plant uptake charts, I need about 84 units of phosphate, 420 units of potash, some calcium, some magnesium, some sulfur. I have, on that second line, you can see not quite as much nutrient as perhaps I need on some of those, but others I have quite a bit more. So what would I look at adding to that soil as far as dry fertilizer? I'm going to add about 30 units of nitrogen, maybe even a little bit less than that. I'm not going to apply any phosphate because I have plenty out there to work with. I will watch that plant to make sure it's getting adequate phosphate. I'm going to add about 200 units of potassium, even though I know there's no place for that potassium to attach. I've got, technically speaking, 4 extra units, but I can't take that number to 0. That number will never get to 0. I'm not adding any calcium, magnesium. I am going to add some sulfur. So basically what it boils down to, what I would do if this was my soil and I was growing tomatoes, I'd put on about 100 pounds of ammonium sulfate because I want to bring my sulfur up. And Anthony mentioned that yesterday. That sulfur test is not really accurate. I think that sulfur test for most labs is completely inaccurate. Plus, I like a lot more sulfur out there. Tomatoes, all of those flavors that when you bite into a nice ripe tomato, those are all sulfur compounds. So sulfur, particularly in tomatoes, is going to be really, really important. I may put on 50 pounds of MAP. I probably would not. I'll save that for later. I would put on a couple 100 pounds of potassium sulfate. That's going to give me about 100 units of potassium. It's going to give me a little bit more sulfur. And based upon my experience, I don't know if y'all have this, magnesium deficiency, even though we have magnesium in our soils, is very common out in Michigan, Indiana, Ohio, Pennsylvania. So oftentimes we tell guys to put on some extra magnesium. But so you can kind of see that, okay, I've taken my soil analysis. I'm not really following a lot of what that soil analysis tells me because, again, I'm looking at the crop itself as much as what I have to work with in that soil. And if I'm not very familiar with that soil, I don't really trust those numbers because just because it's there in the soil doesn't mean my plant can get it. But there's a number of ways of fertilizing your crop. I was discussing the dry fertilizer materials that I would incorporate into my beds. generally speaking, we're going to have about 20, depending upon the crop. If it's irrigated, we have drip lines, something like this. We'll put on normally about 20, maybe 30% of the nutrient requirements in that bed. If it's a dryland crop, such as pumpkins, oftentimes we'll put on about 50% of the fertilizer that's required. Part of what we're looking at there is, okay, what do we need as far as nutrient? Then what delivery systems do we have later in the season? In a dryland situation, I just don't have the delivery systems to bring in additional nutrient like I would in, say, something that's irrigated, particularly through drip lines. So we're not putting much of the material down dry. We are putting a little bit, just to ensure that we can get everything at a base level. Transplant solutions, most of the guys growing tomatoes, peppers, oftentimes melons, a lot of times even onions. We do use a transplant solution. There we use some rooting stimulants such as metabolic seed boost. We may put another biostimulant such as metabolic HV1 in there. We also use some materials, some trichoderma fungi, a product called Tiffy Max. We do some biological activities there also from that standpoint, live organisms. Generally speaking, we put a small amount of nutrient, but generally that nutrient is going to be less than 1% of the overall required for the growing season. It's just basically to help that plant settle in and get comfortable in its new home. Side dress, fertigation. You know, even if we're farming dry land, we can come in and side dress some nutrient, but through fertigation and on high value crops, I really like fertigation, just simply because it lets us manipulate that crop in a wide variety of ways. And generally speaking, we're going to look at about 50 to 80% of all the nutrient that's required by that crop coming through fertigation. We can foliar apply nutrients. Generally, that's closer to 5% of the total nutrient requirements than 10, but you can be out there foliar spraying a lot if you want. The problem is it's very time consuming. Most of our growers, they may target 6, 7 foliar applications in a season. If they get 4 on, they're doing real well. Because produce takes a lot of time. It just does. This is a very efficient way of applying nutrient. This is very efficient. One thing that I didn't make a comment on, I said drip lines. No produce crop should be watered overhead. Part of our goal with our produce crops is to keep that plant surface as dry as possible. And the reason is because of diseases. That plant leaf starts getting moist, particularly going into the evening. Most of the things I've read, if you are going to overhead water it first thing in the morning so that plant can dry out. And but you have those plants going into the nighttime wet, you are definitely asking for some disease issues, and you will get them. So again, we're kind of down now to looking at the individual plants. I made the comment roots, tubers, modified stems. We kind of have a certain approach with those crops. Our fruiting forms. You know, I put cauliflower in there because a lot of people don't think of cauliflower as the fruit. That is exactly the fruit. That's where your seed's going to come from, your seed heads. I mean, it's kind of a energy storage aspect too, but that is the fruiting form. We don't have a lot of produce crops that we actually eat the stems. Asparagus is one of them, but you know, we just grow these plants differently. And part of how we're doing this is we look at nitrogen and water over here on this side, my left side. We look at fruiting, reproduction, flavor, storage ability is all over here with minerals on my right-hand side. And just like that little teeter-totter thing shows, I can manipulate that, particularly if I have drip irrigation, where I can add nutrient in to change the makeup in that plant sap itself. It's the nutrient content of that plant sap that's going to determine whether or not a plant's wanting to get overly vegetative or I really want to enhance fruit set or things like that, that can all be manipulated by changing the nutrient content of that plant sap. So generally speaking, on root crops, we're going to have a fairly aggressive early push. In other words, I want to get that crop up and growing. It's really important, like on a carrot or a beet, I want a lot of vegetation above ground. The more vegetation I have above ground, I can collect more solar energy, and that root, the part that I'm going to consume, that's a storage unit. So the more energy I can produce, the more is going into that root, and I can size that up and make an impact upon how well it's going to yield. Now, as I get closer to harvest, I'm going to drop that nitrogen out, and I'm going to really start bringing in calcium. I'm going to start bringing in potassium. I'm going to bring in all the minerals because, as I said, this is flavor over here. Everybody needs to understand nitrogen tastes like garbage. I mean, it just does not taste good to us. What tastes good to us is all these mineral components. So as we get closer to harvest, really switch your entire approach around where now I'm going high mineral. I'm trying to decrease nitrogen in that plant sap, so when I bite into that carrot, it's got a nice sweet flavor, not a bitter flavor. On vegetative crops, we're going to have a moderate vegetative push throughout almost the entire season. We will watch that crop. We will see, okay, is it growing in a manner that I'm satisfied with? If not, then I can push it a little bit heavier. But again, once I get close to harvest, I'm going to try and drop that nitrogen down. How many of you have ever eaten bitter lettuce? There's just too much nitrogen in the scenario. You can change that. And bitter lettuce really isn't all that great. So we're going to bring the minerals up again as we get close to harvest. Fruiting crops, we're going to be somewhat balanced at the beginning. We will make maybe a minor vegetative push because I am wanting to build that frame up. But I'm going to be, throughout most of the season, I'm going to be predominantly minerals because I'm trying to set more fruit. I'm trying to increase the potential harvest of what I'm growing there. And, of course, the two that's most important is phosphorus and particularly potassium. But every produce crop uses a lot of potassium. May need, it says there, one of the things we're doing with tomatoes and peppers, this is very common. We've done everything right for that first 30, 40, maybe even 60 days. We have this beautiful fruit set on that plant. Next thing you know, you're starting to see fruit up close to the top of the plant. What that plant's telling you there is, I'm about done. I've done everything you asked. I've set all this beautiful fruit on there. You've been kind of mistreating me, so I can't keep growing. The plant will take all of its energy. A plant will literally cannibalize itself trying to mature those fruits. I mean, it's just like a mother. A mother will go through a lot to make sure her children are okay. And that's exactly the way plants are. So once you start seeing fruiting forms, tomatoes, peppers, whatever, close to the top of your plant structure, that's that plant telling you that I'm just about done. I'll try and do as good as I can to finish what I got, but I ain't setting any more fruit on this plant. And you'll start seeing fruit or bloom abortion. You may even see small fruit abortion, etc. So anyway, we're going to go through tomatoes just a little bit. Whoever drew these diagrams has absolutely zero concept of the way a tomato grows. But it's the one I found, so I put it in there. And the reason I'm saying that, I do not know how many million tomato plants I've observed. I've never seen one set a tomato on a branch like that. Tom, I know you haven't either, have you? But anyway, it's what we got. Some of the things that a tomato plant is going to go through as far as a progression during the season, and every one of these is pretty important: seeding, germination, emergence, early vegetative development, initiation of early fruiting forms, setting of early fruits, the maturation of first fruits. All of those are going to require somewhat specific conditions, nutrition, etc. With tomatoes, peppers, plants that set multiple fruiting forms, Once we get into this, then it's just going to go back and repeat the last 3. In other words, hopefully, at the end of the season, you have more tomatoes, you have more peppers on your plants when frost gets them than at any other point in the season. If you've done everything right, you will have. And you will also be really happy to see that frost come because you are tired of picking tomatoes. I make a comment quite often. You know, these plants don't quit on us. We quit on the plants. Gardening, growing produce is hard work. I mean, really hard work. So, you know, we wake up this time of the year, we're going, boy, I can't wait to, you know, get a little bit warmer temperatures. I can get out there in the garden and get my hands dirty. I can have a lot of fun. As the season progresses, like say we're in August now, you wake up, you're not very excited about going to the garden at all. As a matter of fact, it's like a chore. So oftentimes it's we that quit on the plants, not the plants quitting on us. But at seeding and germination, emergence, minimum temperature is 50 degrees. Optimum is 60 to 70. If you want that seed to germinate, it's got to be above 50 degrees. And if you get it up at 60 to 70, it's going to come up a little bit more rapidly. It's going to come up with a little bit more vigor. Water, we want it moist. We do not want it wet. We never want wet. There's not much nutrient required at that point. We do put biostimulants, metabolic SB, Tiffy Max. We start putting in some silicate materials to start helping to build that plant's resistant to disease. Oftentimes we'll use maybe some phosphites at that point. We are doing some things, but the overall nutrient requirements is really low. I made the comment about metabolic SB. I think every one of our growers uses that product. And SB stands for Seed Boost. It just helps bring your seeds up more uniformly and develop a stronger root system. This is some work we did out at Penn State University, just looking at evenness of emergence. And evenness of emergence is kind of important, and it's really important in things like corn. Any corn plant that comes up 2 days after the majority of the crop, that's not a corn plant anymore now. That's a weed. And you will definitely be able to pick those out when you're going in late in the season and looking at the ears, et cetera, et cetera. So uniformity of emergence is really, really important. And you can see, you know, for the most part, we're making a pretty significant impact in this time frame. Then eventually everything did come up. Well, I took those plants then, and this is just looking at red morning tomatoes here. The plants on the right had Seed Boost. The plants on the left did not. You can see a visual difference in the rooting. Why is that important? Well, because that's how the plant's going to feed itself. So it's kind of important that we have a nice root structure. And, you know, I made the comment earlier that a plant is nothing but an energy conversion factory. So the more plant tissue, the more leaf coverage I can get, the higher amount of solar energy I can absorb. So anyway, I dissected all these plants. On red morning tomatoes, I saw a little bit taller plant. You know, 2.83 to 3.55 does not sound like a lot, but I'm already starting to build that larger energy collection capability. The root length, a significant difference there. Scarlet red tomato, somewhat the same thing. So I'm already seeing all the things that I'm wanting to see. I'm getting a really nice root development. I'm starting to send out leaves so I can collect more solar energy, which is going to power that plant to additional growth, etc. A lot of people like to plant tomato plants this big. I can't think of anything worse than that. I like a tomato plant. It's really ready to be transplanted. This is, I just pulled this out here several weeks ago. I did tell the grower put in a little bit of phosphate because they didn't like the coloration. But that plant had been planted for basically 2.5 weeks. And I can already pull it out of a 72 cell tray. So generally speaking, I tell guys, I want my tomato plants, my pepper plants, and things like this that you're transplanting when that third leaf is moderately well developed. They're still going to be kind of small, but when that third leaf is out, I like to see that plant transplanted. Temperature, minimum of 65, 70 degrees is better. Water still moist, not wet. Nutrient requirements are still pretty low. It is starting to increase. One of the things that tomatoes is very susceptible to early blight. This is about 5 years now. I've had no early blight. And part of what I do is I start bringing in 4-18-38 really about 4 days to 7 days after transplanting. It's in my first watering, and that gives me a little bit of potassium. I'm not putting on a large amount, just a little bit of potassium for that plant to go ahead and support itself. Because a lot of our diseases, like in early blight, it'll start down at the oldest leaf. The oldest leaf, if we're starting to see degradation, that's probably a sign of, okay, either I had it way too crowded, my plants are too big, and my transplant trays, my growth trays, so I'm not getting enough sunlight, or I'm already seeing a potassium deficiency. The plant will pull potassium out of that oldest leaf, move it up to the growing point or to any fruiting forms, which it would not be at this point. But it's that plant moving potassium out of that oldest leaf. When that happens, that cell collapses. Once that cell collapses, it's just like this right here. It's now a cut. That was a potential site of infection. It's not now because it's all scabbed over. But any degradation of those cells, those collapsing of those cells, is now an open wound on that plant where a pathogen, if it happens to land in there, then here we go. And we really don't want that. So I do start pushing potassium fairly early. Spacing, a lot of that depends upon the variety, how you're wanting to grow them, etc. Most of our guys space them 18 inches in a row. If you're growing heirlooms, I definitely recommend 36, just simply because all of these varieties are going to grow differently. An heirloom tomato, you can grow that 15 feet tall if you want, really easily. Most of our determinate hybrids, you can still take them up to 6-7 feet, but generally speaking, 4-5 is going to be more common. And the rows themselves, I like them at least 4 feet apart. Tell you the truth, I like 6 better because I have to go in there and pick that stuff. And a 4-foot row, a tomato plant, when we're at the height of the season, it'll be 2.5 feet wide, and that's with you tying and supporting and everything else. So part of it is also airflow. Yeah, that's why I said I told this guy I'd push a little phosphate. A lot of our guys sucker, and by suckering, not too much past this stage, we're going to start seeing another little structure coming out of that node position. And tomatoes will put out a sucker at every node. A lot of other plants do also. The reason a lot of guys pinch those off is to direct more of the energy to the primary part of the plant, not trying to grow all of that extra vegetation. Plus, that extra vegetation really starts inhibiting airflow. And you can get this massive plant that air doesn't flow through there, and then disease is going to be much more prevalent. At some point, you do have to stop suckering, but most guys do sucker. And the rule of thumb there is don't sucker wherever your first fruiting truss is visible. Don't sucker up to within 2 nodes of that. You can sucker that second one down, but don't sucker underneath that fruiting truss. The things I'm looking for at this point, we should start seeing some good vegetative size, some good leaf size. I want good color. I want my leaves to be more or less horizontal to the main stem. That's an indication that the plant's growing pretty vigorous. I'm really watching my node spacing. I made the comment that, I can grow a really tall plant, I can grow a short plant, I can grow a plant this height. That is somewhat up to you. And I want my nodes on tomatoes to be generally 2 to 4 inches apart. And by nodes, I'm talking about wherever a leaf structure is coming out of that main stem. If you start seeing node spacings of 6, 7, 8 inches, that you're way too high on this nitrogen side, probably. you can slow that down. You can add minerals and change the nutrient content in that plant sap and signal that plant, don't vegetate quite as aggressively. I want you to be over here on this side. If you're starting to see node spacings an inch, well, that's not enough room to set tomatoes. So you want to say, okay, hey, I want you to get just a little bit more aggressive. I'm going to give you a little bit more nitrogen. I'm going to stretch that node spacing up a little bit just so my fruit can set and mature in there properly. So that's something we're always looking at, is our node spacing. Okay, we've got our plants in the ground. We're starting to see maybe some initial fruit trusses. Nutrient requirements are definitely starting to increase. The things I'm looking for is still the oldest leaves. I'm not wanting to see older leaf degradation. I'm definitely looking at my fruiting trusses. There should be 6 to 8 buds minimum. Generally speaking, whenever you see something like that, like in this plant here, there was 2 more fruiting trusses in the top of that plant that were initiated and were starting to become visible. If you have any questions on nutrient content, you can always run a tissue analysis. This would be a point where we would run our first tissue analysis. It's recommended to start thinking about your support system. It is not a good idea, in my opinion, to grow tomatoes, just let them flop over on the ground. Wherever a fruit happens to touch that ground, there's a very high probability that will not be a harvestable fruit. So normally we're running some kind of support system. Here you can see we've run steel stakes. We're going to come in with tomato twine. We do a Florida weave for the first couple of string applications, and then we just kind of do what we refer to as kind of a box type system. Temperature at this point is 70 degrees. A lot of the things you read on tomatoes, they'll set fruit at 65. Well, not real well. I like it to be about 70, maybe even in the low 70s. Water, moist, still not wet. Our nutrient requirements are really starting to go up. We use a lot of 10-20-20. It's a very high energy material to encourage that plant to set a lot of fruits. We use 4-18-38 to support the fruit growth, fruit quality. We're really continuing to build the plant's immune system with silicates, siphyte, things like this. Tomatoes are self-pollinating. They pollinate predominantly through wind. Some guys will bring in bumblebees, things like this, but that airflow, that wind able to flow through your houses or even out in the field is extremely important. As I said, I'm still observing the older leaves. This just kind of gives you a slide idea. I don't think it's completely accurate, but just the nutrient uptake charts as far as nitrogen, phosphorus, potassium, some of the secondary nutrients. And you can see at the front of the season, like we've been saying, the nutrient requirement's pretty low. But as we start growing that plant, particularly as we start getting into fruit set and maturation, those nutrient requirements just skyrocket. I just saw these tomato plants Monday down around Alexandria. And you can kind of see some of the things I've been talking about. Look at these lower leaves. They're all still got very good color. They're still intact. They're not seeing any degradation. And some of those lower leaves were literally 18 inches to 20 inches long. Really nice leaf canopy. You can see some of the fruiting trusses. There's 10 potential fruits here. There was at least 3 trusses on every plant. On that 10, I asked the grower, I said, so how many of these are you going to leave? He said 4. I mean, we're always pinching off potential fruits. Part of the reason we do that, if you're growing for your personal consumption, you don't have to do that. What you're going to get is you're going to get 4 or 5 maybe really nice #1 marketable fruits. Then you're going to get some canners. It's very difficult for that plant. I like to see uniform fruit size on every fruit. That's very, very difficult to do. So a lot of our guys who are growing for resale, they do prune 4 or 5 tomatoes per truss. And you can see here, This is another thing that we're always looking at. This is the growing point up in the top of the plant. And you see how fresh it looks. I mean, I always use the term, it reminds me of Ireland. The pictures, I've never been to Ireland, but the pictures I've seen of Ireland, it reminds me of that. It's just different shades of green. And I want to see a lighter coloration right here in the center of that leaf coming out to maybe halfway to the leaf tip. And you can kind of observe that. Now, here, I think I'm picking a little bit of light coloration up, but what this tells me is I'm probably pretty good on nitrogen. If this is dark green all the way to the base of that leaflet, it's telling me I'm too high in nitrogen. That plant's going to try and stretch up on me. If it's pale all the way out to the leaf tip, then that tells me, obviously, I don't have enough nitrogen, and I'm probably going to start seeing some issues. So these are the kind of things that we're always looking at. And I recommend to anybody, when you got your plants growing, get you a cup of coffee in the morning. The weather's normally beautiful. Go out there and just sit among your plants and look at them. I talk to them too. You know, you got to have somebody to talk to, right? I mean, just really look and question, wow, why am I seeing that? Isn't that fascinating? I mean, you really learn how these plants grow. There's a growing movement. It's called forest bathing, where a person just goes out amongst the woods, a forest, and they sit there and they just listen and they observe. And it's supposed to be very good for your soul. Well, I get that same exact thing. I guess you could call it garden bathing. I mean, oftentimes as growers, we're just in a rush, we're in a hurry. We aren't really paying attention to what's going on out there in our growing area. But I highly recommend doing that. I mean, you will learn a lot. Do we have time left? Okay. Okay. Ray, I told Ray, give me a little sign when I'm 15. I missed your sign. But we were going to get into some root crops, some melons. The one thing that I want to say on your melons, real quick, a lot of our modern cucumbers, they're parthenocarpic. They have a fruit on every flower. But cantaloupes, watermelons, you have male and female flowers. And most all the flowers that are going to come out on a watermelon or cantaloupe are going to be initially male. And that's the way it should be. There needs to be enough male flowers out there so when the females come, we're going to get really good pollination. Generally speaking, the females should start showing up maybe 10 days after the males. And again, you can manipulate that. If it's been 2 weeks, it's been 2.5 weeks, and I'm not seeing females, females will always have a little barrel, but the stem, a barrel, and then the flower. A male will just have the stem and then the flower. So you're looking for these little barrels. And if you don't see that, you can manipulate that plant, the nutrient content in that sap, to bring on more females. This over here is vegetation. This is also male flowering. If you don't have a lot of males, then you can add some nitrogen and you can increase the number of male flowers that plant's going to give you. This over here is reproduction. This is your females. So if you're seeing a lot of males, you're not seeing females, you can adjust that through nutrient applications. So with that, I appreciate it. Thank you very much.